Hello, Honors Geometry. This is Miss McCahan. Sorry I can't be there today, but I'm going to still do your lesson. So first we're going to talk about classifying polygons, and we need to really think about what is a polygon. So I have all these shapes, and we're going to put them where we think they should go. So think about, whether you think a star is a polygon, whether a circle is a polygon. So think about that. Some people might think yes, some people might think no. The spiral, that's not a polygon. This one, some people might be confused about, but that's not a polygon. And I'm going to talk about why all these shapes are and are not in just a minute. Believe it or not, this X is a polygon, the arrow is a polygon, and the square is a polygon. But this little say bubble is not. And if we go back to this circle, that's actually not. So if you were wondering about that one, that is not a polygon. Who doesn't want to go over here? Alright, so these are the polygons. And over here, these are not. So we're going to talk about what makes those not polygons. So, definition of a polygon. What I've done is I've taken the definition and I've broken it up into the pieces, and I've given you examples and counterexamples. So, a polygon is a closed figure. I'm going to highlight that. So, a closed figure. That means that if I think of this as like a room, it's a sealed off room. No one can get in or out. Whereas this one over here, you see how I could just like walk right in that room. Okay, so it has to be closed, so that's why that spiral was not a polygon. It has to have 3 or more. When it says 3 or more, we're talking about sides. So obviously this quadrilateral has 4 sides, but this only has 2. It's trying really hard to be a polygon, but it's not, and that 2-sided figure means it's always open. Coplanar means that the sides have to be coplanar, and usually we don't have to worry about that. Usually the 2-dimensional objects that we're drawing are coplanar. However, if I were to trace the edges here on this box that they're talking about, so this edge and this edge, notice that these 3 segments are on the top side of the box, and then these 3 edges are on the side of the box. So if I was looking at this within a 3-dimensional context, then that would not be a polygon. Now, if I were to take those 2 things and take them out of that 3-dimensional context, like that, that would be a polygon. So it just looks like a 2-dimensional figure and it's closed and everything. That would be a polygon. It's when it's in a 3-dimensional context that it makes it not a polygon. So just be aware of that. We don't come across that often. Alright, now the sides have to be segments, so I think we knew that. But that's what makes that circle not a polygon, because it can't have any curved sides like that. Also, some things that you might not have thought about is that the 2 sides with the common endpoints have to be non-collinear. So if I have this side and this side of this polygon, notice that the red line and the green line, they're not on the same line. Okay, however, if I was looking at this one over here, this is trying to say that AD and DC are 2 different sides, and it's not. Notice that they make the same line. So this whole side, AC, would be a side, but we can't just cut it in the middle and say, oh, AD is a side and DC is a side. That's not what is true in polygons. Alright. The next thing is each side intersects exactly 2 sides. I'm going to focus on this word exactly. Exactly means no more, no less. So again, I'm going to highlight one of these sides. So we have a red side. So it has to intersect exactly two sides. So there's the first side, and there's the second side. So it doesn't touch any other more. It doesn't touch any one more at all. So it's not three, and it's not just one. It's exactly two. Whereas over here, if I'm talking about, let's say, this diagonal side, this red side, it touches this green diagonal side. It touches the top side, and it touches this bottom side that's black. So it's touching three sides, and that violates that exactly two sides part. So on the beginning page, that's why that one's not a polygon, if you were wondering about that one. And then our last one, the sides can intersect only at the end points. So if I have a side here, it can only touch another side at the end point. So here is where the next side starts. At this end point is where the next side starts. The problem with this one over here is that this red side keeps growing. Look at that. So it was supposed to stop once it hit this side, but it didn't. So that's not allowed either. So hopefully that helps clear up some information about sides. And also, I hope it clears up information about polygons. So let's move on. Naming polygons. Each endpoint of a side is a vertex. So I think you guys have heard the word vertex. So you don't have to write all of this stuff. You might just want to draw this diagram and then just label what the vertex is. So I could say that B is a vertex. So you might just want to draw an arrow and say, oh, that's a vertex. Sorry, my arrow's a little sloppy there. So that's a vertex. Now, something that you might want to write down, though, is the plural of vertex is vertices. I got a few questions on our first test about that. So yeah, vertices just means more than one vertex. Okay. When we name a polygon, we have to name it according to the vertices. So you want to start with one of your vertices, and it doesn't matter which one. So if I start with A, then I need to go in order around the shape. So I need to say A, B, C, D, E. Okay, so I need to go around the polygon. Or if I could start at A, and then I could go around this way. A, E, D, C, B. All right, so it doesn't matter where I start or if I go clockwise or counterclockwise. I just cannot skip around. So I can't do A, D, C, E, B. That's not an okay way to label that polygon. All right, I think we've talked about sides and vertex of a polygon, so don't feel like you have to write this down again. You might just want to go back to our shape here and say, oh, well, this is what we would call a side. So AB is what we would call a side. All right. Let's move on. So let's talk about classifying polygons. We can do that in different ways. The first is by the number of sides. So you probably know some of these already, so if you know them, go ahead and write them down as you go, but I'm going to write them down up here, and you might want to make sure that you're getting those correctly. So obviously a three-sided polygon is a triangle. And you know what I might do? Since it takes me so long to write these, I'm going to pause the video. You write down what you think the names are, and I'm going to write them down too. And then when I unpause the video, the answers will be there. Alright, so 4 sides is a quadrilateral, so make sure you don't put like square or rectangle. Those are specific types of quadrilaterals. And we will talk about those in the second semester. But yeah, 4-sided figure is a quadrilateral. Then we've got pentagon, hexagon, heptagon. Make sure you put heptagon and not septagon. Octagon, nonagon, and decagon. And then this wasn't in our table, but let's go ahead and put 12-sided as dodecagon. Alright, so those are words that I need you to know because in directions I will be describing different polygons to you, and you need to know how many sides there are. I wouldn't worry about like spelling or anything like that, but you need to know what each of those mean. Now what about like 11, because 11 got skipped? That would be one of those other ones that we use with the n-gon. So if I wanted to talk about an 11-sided figure, I would just say, oh, that's an 11-gon. So I kind of like that system. I wish it was used all the way through. That way we wouldn't have to remember special names for all of those, but this is what it is, so that's how you do it. So if I wanted a 13-sided figure, that would be a 13-gon. Alright, so anything else that's not in that table is just going to be the number dash gon. Now we can also classify polygons with their measurements. So you could have an equilateral triangle or an equilateral polygon, and that just means it has all of its sides congruent. So for example, if I was talking about an equilateral triangle, I would want to show that all of those sides are congruent, especially with my horribly drawn triangle. I'm going to mark that with congruent sides. That way you know that that's supposed to be 3 congruent sides. Now this word you may not know, it's equiangular. So it looks like it says equal angles. So a polygon is equiangular if all of the angles inside are congruent. So if I wanted to draw an equiangular triangle, I would just make sure that I mark all of those angles congruent, and remember we do that with those arcs. Right, so that would be equiangular. And then another new word that you may not know is regular. Regular means that it's both equilateral and equiangular. Okay, so all sides and all the angles are congruent. So I would have a triangle that looks like this. I'm going to mark all the sides and all the angles. So again, for quadrilaterals, if you think about that, so a square would be regular. And think about, what about a rectangle? Is a rectangle regular? No, all the sides are congruent, but it is equiangular, right? A rectangle has all 4 angles are right angles, so we would know that that's equiangular. So I'm just trying to give you some examples of regular versus not regular and so on. Alright, we can also classify polygons by other methods. So what we mean by other methods is we can either call them convex or concave. Alright, and if I want you to think about if you've studied lenses or mirrors, a convex mirror or lens kind of bends outward, and a concave lens or mirror bends inward towards itself. So I'm going to draw a convex polygon. And according to this definition, it says that any line that contains the side will not pass through the interior. So if I draw these blue lines that contain the sides, notice that those blue lines stay outside of that shape. They don't go inside of that pentagon. Okay? However, if I had a concave pentagon, I'm going to draw a concave pentagon. So it's going to be like a house, but the roof isn't going to be up, it's going to be collapsed. So that's what I use for my concave polygon. Alright, so in this situation, if I were to extend that side, do you see how if I put a line through that side, how that red line cuts through the middle or the interior of that polygon? So that's what makes it concave. So that's what we mean by those definitions. I like to think of it as, does it cave in on itself, or is it just bending outward at all edges? So let's go through these. Alright, so we need to tell whether each figure is a polygon. So it's going to be yes or no, it's a polygon, and whether it is convex or concave. So this first one, is it a polygon? No. So I'm just going to write N for no. Okay, and it's because we can't have that line in the middle. That violates a side touching exactly two sides. This side is touching four sides. Alright, so that's a no, it's not a polygon. But if I got rid of that, it would be convex, wouldn't it? So I'm going to put vex, just so I don't have to write out the whole word. Alright, let's go to this next one, B. Is this a polygon? Yes, it's a polygon. And it is convex. This one over here, is it a polygon? Yes. And do you see how this kind of caves in on itself? So that would cross that line, so that means it's concave. Alright. This next one, yes, it's a polygon. And it's convex. And then this one's not a polygon because it's curved. It has a curved side. Can't have that. Alright, moving on. Alright, so now we're going to classify this by the number of sides, tell whether the polygon is equilateral, equiangular, or regular. So if I start counting here, so that's 1, 2, 3, 4, 5, 6, 7, 8. Alright, we got an octagon. And then notice that they have all of their sides marked with tick marks. So that means that it is definitely equilateral. And then all of the angles are marked with arcs, so it's definitely equiangular. So that means it's also regular. So rather than saying both equilateral and equiangular, we say it's regular. And regular polygons are useful because, like in this next problem, if I tell you that this hexagon is a regular hexagon, so notice it says here in the directions, okay, then I know that these sides are congruent. So if I know those sides are congruent, then I can set 4x plus 3 equal to 5x minus 1. So let's do that. 4x plus 3 equals 5x minus 1. You solve that right now, and I'm going to pause the video, and then your answer will pop up. Alright, so you got x equals 4, and then when you plug that back in to find the side of the length, you get 19 millimeters. So in this last one, we can see that it's not equilateral because all sides are congruent, and it's not equiangular. Even though these two are congruent and these two are congruent, they are not all congruent to each other. So we can't call that equiangular or regular. Okay, we're going to skip that one. So let's talk now about 1.7, which is perimeter and area. So remember, perimeter is the distance around a shape, and area is the amount of space inside of a shape. And here we've got specifically a rectangle, and these were those formulas for a rectangle. On this page, I just have reminders of some formulas. So for a square, remember that Yes, we can just add up all the sides for perimeter, but since all the sides are the same, so they're all S, we can use 4S instead of just adding up all the sides. Same thing with area. I can do length times width, but I know since they're the same thing, that's just side squared. Rectangle, that's what we were just looking at. So remember that since two of the sides are the same, I can just say for perimeter, I can add those two. That'll be two lengths. And then the two widths would be 2L plus 2W. And then the area is just length times width. For the triangle, the perimeter formula is pretty silly. You just add up all the sides, A plus B plus C. And then I know you remember the area formula because we did that on our last test. 1/2 base times height. Now the last one, circle. Remember that C stands for circumference. And remember, circumference is just another word for perimeter, but it's specifically for a circle. So that's the distance around the circle. And then in our formula, we have 2 pi r. And remember that the r stands for radius. And remember, in a circle, a radius is the segment that connects the center to the edge of the circle itself. So this is the radius. All right, and then for area, it's pi r squared. Don't forget that pi is that number 3.14159. All right, we usually use 3.14. Unless it says in the directions to do something else, use the pi button on your calculator. All right, so let's look at some examples. I want you guys to try to find the perimeter and area of all three shapes on your own right now. And when you get done, check it with your face partner. And then I will put the answers up here, and you can look at the answers. All right, so you should be getting these answers for your perimeter and area. Be careful over here on the circle. I gave you the diameter, so that means the radius is 11. And since the directions did say to use 3.14, I used 3.14 to get this. If you use the pi button, your decimals might be a little bit different. Okay, and in this one, we have to find the area and perimeter of a triangle. So we have to graph our points. So I'm going to graph J, 1, 4. And then K is 9, 4. And then L is 4, 0. So I have this triangle. So I need to find area and perimeter. Let's find the area first. That will be easier. All right, so if I'm finding area, then I need to do 1/2 base times height. And if it were me, I would choose JK as my base because I can count how long this is. This is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units long. All right, so I know I'm going to do area is 1/2 times 8. And then I need to find the height. Remember, the height has to be perpendicular to the base. So I can count that. So that's going straight from the base to the opposite vertex. So that's 1, 2, 3, 4. This has a height of 4. So I'm doing half of 8 times 4, so that's half of 32, which will be 16. And I don't have units, so I don't have to worry about that, but I could just say units squared if I wanted to. All right, and then for perimeter, I only have 8. How am I going to find the distance, the length of JL and LK? Well, yep, you guessed it, distance formula. So if I do distance formula, remember, let's see, if I do JL, that's going to be equal to the square root. So I'm going to put square root, but it may not show up all the way across. I can't get a really long square root. But just know that it's going all the way across. So that's square root of my x-coordinate for L is 4, minus my x-coordinate for J is 1. And then I have to square that. Then I have to do plus my y-coordinate for L is 0. Then my y-coordinate for J is 4. And then I need to square that. So what is that going to give me? That's going to equal the square root of, so let me get the square root of 3 squared plus 4 squared. And that's going to equal the square root of 9 plus 16. Which is going to equal the square root of 25. So what's the square root of 25? That's just 5. So I know that JL is just a distance of 5. And then we have to do the same thing for LK. So you try to do the same thing for LK right now. I'm going to pause, and then you'll see the answer when you're done. All right, so for LK, you should be getting 6.4, and here's all the work for that. So you can see that it's the square root of 41 is about 6.4. So if I add all of those sides together, I should get 19.4 for the perimeter. All right, so again, try these. I want you to try them and then check with your partner to see if you're getting them right. Okay, so for this first one, you should be getting 9 bags of mulch. You find the area, and then each bag covers 8 square feet. And so if you divide your area of 72 by 8, you should get 9 bags. And then on this last one, you are given the base of the triangle is 24 and the area is 216. We need to find the height. So I've plugged into our formula and I'm solving for h. Just be careful there. Some of you will divide by 24 first, and then you'll get 9. Remember that 9 is not your final answer. You still have 1/2 h. So don't forget about that 1/2. So you should get a height of 18 feet. So guys, here's your homework. It's 2 pages. That first page, page 44, is all about the polygons, and the second page is all about perimeter and area. If some of you have a book, maybe you can be kind enough to let some people take pictures of it so other people can work on it. And if you have any lingering questions, maybe about your previous homework, maybe you can ask each other. That's probably a good way. I'm sure some of you know, and if not, then I'll cover those next time in class. Thank you guys for listening.